This is part 2 of the wall climbing system, so make sure to watch the previous part first if you haven't. Now we will finally work on the input event, which will add most of the functions and macros we have made for movement. Make a new custom event called wall climb input. Add a branch that checks lock wall climb. If false, add the can wall climb initial check macro. Since these were all explained when the macro or function itself was made, I will not repeat their purpose here. If the macro is true, add the wall climb trace location function. Then add a branch that checks can wall climb. If true, add another branch that checks the wall climb distance check function. If true, get character movement and set movement mode to falling. This is since we want default movement for only left and only right to be falling, and we set the movement mode to flying in the movement selector macro if moving up, down or diagonally. Next, add the wall climb movement selector macro. Then add the wall climb hit macro, connecting up to up and down to down. If hit not found, add a branch that checks exit on move down and can exit on move down. If true, call exit wall climb. If hit found, get the motion warping component and add or update warp target. If you don't have this component, you can add it using the add button in the top left. Split the struct pin. The warp target name is wall climb move to, and make sure it is named exactly as the one in the montages. Get the wall climb hit result and break it. Add a vector to the impact point and multiply the normal for it. Convert it to a float and add a select node. Get the actor rotation and multiply pitch by -1 for condition A. B will be 0 and the condition is pitch greater than 10. We are adding an offset to the location if the actor is rotated, since I found errors with the player being pushed away from the wall if they are rotated on a downward slope, so this moves them closer to it. Next, set lock wall climb to true and stop movement immediately. Then get the mesh and play montage. The montage to play will be the wall climb montage function. Get the IK mesh and play the same montage for it. The purpose for this invisible IK mesh will be explained in more depth when the hand IK code is being done. On notify begin for the regular player montage, set lock wall climb to false. This is why we added that wall climb reset notify, since on blend out and on completed can't be used here since the animation loops at the last frame. Then set the previous animation to a select node. The condition is move x less than 0 with false being right and true being left. This variable is being set so that if we transition from left to right, it plays the first part of the animation even if it ended on the second. I will now comment the event. For the last part of the move input, make a new function called wall climb to top trace. This will be used when the player is at the top of a ledge and should check if they can climb. It will have one float input called min angle of default value 20. Add a branch that checks if move y is greater than 0, since we should only climb up if we try to move straight up. If true, add another branch. Get the actor rotation and in range of the pitch. Min should be the absolute value of min angle multiplied by -1 and max should be min angle. This is the condition. If both branches are false, add a return node. It will have one Boolean output called can climb to top and a vector output called location. Leave both at their default value for this path. If the branch was true, add a capsule trace by channel. Copy the nodes shown for the start and end. The half height is being set to lower than the actual capsule half height to compensate for any errors or small objects that are detected but shouldn't obstruct climbing. Add a branch using the return value, and add a return node for both paths. Set can wall climb to top to true in the false path. Then subtract a vector from the start and end location of the capsule trace. We will subtract the capsule half height in Z since the trace had to be offset but not the actual move to location due to motion warping working from the root bone which is at the bottom of the mesh. Next make the macro for it called wall climb to top. Add a branch and connect both pins to the input to make them inputs. Change the Boolean 1 to can climb and make a new vector input called location. If true, set lock wall climb to true. Add or update warp target of the motion warping component and split the struct pin. Set the warp target name to wall climb move to again and the location is the location input. Then set movement mode to flying. Get the mesh and play montage, selecting the braced hang to crouch montage. On the default exec path, call stop wall climb timer and on blend out call exit wall climb. Go to the can wall climb initial check macro in the input event and call wall climb to top trace if false. Connect this branch's false path to it as well. Add the wall climb to top macro and connect the outputs of the function to the macro's inputs. I will now categorize the newly made functions, macros, and variables. Now make some space in the movement input. If you didn't follow along for any other videos in the Parkour series, just add this branch before the movement input. The condition is wall climbing, and if false, connect it to the add movement inputs. If true, call the wall climb movement input. Now we are ready to test the system so far as the main movement part is done. I will make a test map to test all the current features and ones that will be made from now. I will speed this section up so you can skip to the time shown for the rest of the tutorial. The system is kind of working, but there are many bugs such as the player gliding after stopping movement. There are also issues with moving down dropping the player. We will now fix these bugs before continuing with the new features. First is a problem that is caused by the wall run and wall jump mechanics made in the previous videos. If you did not follow along for those, then you won't have this issue, but if you did, then go to the on component, hit capsule component code. Add a branch that checks if wall climbing and only continues the code if false. Next, to fix the gliding bug, go to the wall climb timer. We will add the first part of this. Add a sequence and set the character movement velocity to 0 and then 0. This stops any movement in the player other than the root motion, so the player is not moved any extra since the movement mode is flying. Next, go to the can wall climb initial check macro. I made a mistake here as I forgot one addition. Copy the nodes shown. Now the movement issues are fixed. We will fix the animation being the same soon, but for now we'll start hand IK. Make a new function called wall climb hand IK. It will have one input called target foot with type being the direction enum. It will have two float inputs called radius and normal multiplier with default values of 15 and 5 respectively. Add a sphere trace by channel. Copy the nodes shown for the start and end. Here is where we use the IK mesh. We are getting the socket location of a temporary mesh to modify the hand IK of the main one, because if we use the regular mesh, the location of these bones are going to be changed during runtime, and so when we get the locations of them for the trace they would be modified and not in an optimal location to use for the calculations. So we are instead using a temporary mesh which will play the exact same montages as the main one, but that one won't have any IK, so the bones will stay in the same position as the animation. We are using different bones here depending on the actor rotation, since while testing, if the player was rotated on an upwards facing slope, the IK did not look that perfect when it used the hand bone, but looked better with the lower arm. Add a return node after the sphere trace with return value being an output called IK found. Break the hit result and add a vector to the impact point. Multiply the normal by the normal multiplier input for it. Subtract an actor vector multiplier from this in the up direction with multiplier being 10. Make this an output called IK location. This is a simple trace which traces forward and down for an IK location. The next IK function will be called wall climb hand IK correction. This is a second more precise trace like how we did for the wall climb down trace to try to find a location if the initial one was missed. It will have the same inputs as the wall climb hand IK1 but with an extra integer one called trace amount of default value 12. Add a for loop with break with last index being trace amount. Promote the index to a local variable. Add a sphere trace by channel. For the start and end, first copy this part from the wall climb hand ik function. Copy the shown nodes for the rest. Make a new local variable called retry for this condition. The retry variable will be used to run this whole for loop with break twice in case the first one missed, it will do it again. The first time it will search below for a hand ik location while the second time it will search above. This right actor vector multiplier rotates the trace more each iteration of the loop, so it searches for possible offset locations as well. Add a branch using the return value of the trace and a sequence if true. Then 0 should be break of the for loop. Copy the hit result code from the wall climb hand ik function and paste it here. In then 1, set a new local variable called found to true and the subtract vector to 1 called location. On completed, add a branch that checks found. If true, add a return node with found and location being outputs called ik found and ik location. If false, add a branch that checks retry. If true, add a default return node, meaning no IK location could be found. If false, set retry to true and connect it to the for loop with break. With this setup, the for loop with break can run either once or twice. This trace searches below or above the hand location of the IK mesh if one wasn't found in the default wall climb hand IK function. In the wall climb tick event, add the wall climb hand IK function in then one of the sequence. Add a branch using the IK found output. If true, set IK location to wall climb hand IK right location, which is a variable we made earlier. Next set the wall climb hand IK right alpha. If the branch is false, add the wall climb hand IK correction function. Add the same 3 nodes for this one. Make sure to set both alphas to 1. Copy all of this part and set it in a new pin in the sequence. Replace both target foot inputs of the function and the location and alpha variables to the left hand. The next function will be called wall climb edge IK. This checks whether each hand should be closed or flat based on the IK location. It will have one float input called radius of default value 10. Add a sequence and a sphere trace by channel in then 0. Copy the shown nodes for the start and end. The up vector multiplier is being used with a map range clamp since the offset should vary based on the actor's rotation. Make a new local Boolean variable called left and set it to the trace's return value. Duplicate the code for the right hand and make a new local variable called right for this one. In then 2, add a branch that checks left and right. If true, set the wall climb edge state variable to none. If false, add a branch that checks left equals false and right equals false. If this is true, set wall climb edge state to both. If false, set it to a select node with left being the condition. If false, set it to right, and if true then left. This trace checks close to the IK locations to see if there is a surface above it, which means the hand should be flat, and if not then closed. Add the function in the wall climb tick sequence. Change the radius of it to 7 as 10 was too big. Next, make a function called wall climb freehang tracer. It will have one float input called multiplier of default value 25. Add a sequence node with then 0 being a box trace by channel. Copy the scripting for the start and end. We are again using the IK mesh for this, although it will work with the regular mesh too. For the half size, add a select vector. The condition is velocity is nearly 0 with a tolerance of 2. If true, it should be 5, 2, 10, and if not, then 5, 2, 40. A select node is used here since we only want to freehang once the idle pose is reached and not while moving, since if you are on a wall with multiple gaps it will look weird when the freehang is toggled on and off fastly. The orientation is the actor rotation. Set freehang left to not of the trace's return value. Duplicate the entire trace and add it in then 1. Change the socket to ball_r and the variable to freehang right. This trace does a simple box trace in front of the foot to see if there is a surface to place that foot on, and if not, then it freehangs. Add the freehang trace to the wall climb tick event. Then set freehang left physics alpha to AF interp to with the current being the value of it. For the target, multiply freehang left by a new float variable called freehang alpha clamp. This variable limits the physics blend weight to a select value as one made it swing too much. I will set the default value of it to 0.4, but you can test different values to find the best for you. Set the delta time to world delta second and interp speed to 5. Then get the mesh and set all bodies below physics blend weight. Make a literal name for the bone name, which will be thigh_L, and connect the left physics alpha to the blend weight. Duplicate the last two and change all necessary variables to the right one. I will now comment the event. Now we will do the animation blueprint. Open your character's animation blueprint. I already have the footstep notifies from a previous video, but if you don't, just search the notifies and you can add their events. In the footstep_L notify, set wall climb land foot to left from the blueprint. Character ref here is simply a promoted variable after casting to the third person character blueprint. For the right notify, change it to right. Next we will add all the variables. First promote wall climbing to a variable. Next we will promote wall climb hand IK left alpha. Do the same f_interp to set up like we did for the freehang trace. Also promote the wall climb hand IK left location variable. Next duplicate the previous two and replace where necessary for the right hand. Next will be wall climb edge state. Make a float variable called left edge IK alpha and set it to af_interp 2. The target will be wall climbing multiplied by a float. Get wall climb edge state and check that it is not equal right and not equal both for the second multiply. Duplicate this for the right edge alpha and change not equal right to left. Now make two more float variables called left and right freehang alpha. Set it to af_interp 2 with the target being the corresponding freehang variable from the character blueprint. Now go to the anim graph. If you did not follow along with the previous Parkour videos, then you will need to adjust the code here and place it accordingly, although it shouldn't be too difficult as there is not many changes. Before the slot default slot node, add a blend poses by bool. If true, add climb idle, and if not, then whatever was before it. The active value is wall climbing. After slot default slot, add apply additive, and the additive is the wall climb additive animation we made. For the alpha, drag in wall climbing. Now go to the end of the graph. Add a 2 bone IK. The IK bone is hand_L. Set allow stretching to true and allow twist to false. Effector location space should be world space and joint target location should be bone space. Set the joint target to lower arm_L. The alpha and effector location are the wall climb hand IK left ones. The joint target location I will set as -15, 2, 5, which are values I tested with. Duplicate it and change the bones to the corresponding right ones. Replace the variables with the right ones and joint target location to -15, 2, 5. Then add a component to local. Add a layered blend per bone. This node allows us to play animations on selected bones only. Add a branch filter and set the bone name to hand_L with a blend depth of 1. Set mesh space rotation to true. For the blend poses 0, which is the animation to play on the bones below hand_L, get a T-pose animation. The third-person template comes with a T-pose, but if you are using a custom character you can just use any pose where the hand is flat. The blend weight is left edge IK alpha. Duplicate it for the right hand and replace the values and variables. Next, duplicate the 2 layered blend per bones. Set the bone to thigh_L and blend weight to left freehang alpha for the first one. The animation for this should be the climb idle freehang 1. Replace the ones for thigh_R as well. Next, add a local to component. Add a transform bone node with the bone being hand_L. Remove the location and scale as pins. Change the rotation mode to replace existing and rotation space to bone space. The rotation should be -90, 0, 90. The alpha should be left edge IK alpha. Duplicate it for the right hand as well. Finally, connect it to the output pose. That will be all for this part. The next one will be the final one, which will include the final additions, refining and bug fixes. You can purchase this project using the link in the description if you want. If you enjoyed, like and subscribe for more content. Thanks for watching.